To add rational expressions like 1 over x plus 4 plus 2 over x, we need a common denominator. And really, a least common denominator would be best. So before we look at this problem, it might be good to look at, well, what if we were adding something like 1/3 plus 2/5? What is the least common denominator in this problem? And since 3 and 5 have no common factors, you can just multiply the two together, and that gives you 15. So you would take your first fraction, it's missing the 5, and so you'd multiply it in. You look at your second fraction, which is missing the 3, and you'd multiply it in. Your denominator is going to be 15. You would add the numerators of 5 and 6. So 11 over 15 would be the answer. If we use this idea over here, my denominators are x plus 4 and x. And since we're talking about factors, there are no common factors between x and x plus 4. They're completely different. Because this is the case, our least common denominator is going to be the product of both denominators, which I'll write as x times x plus 4. I'm not even going to multiply it out. Since this is my common denominator, I'm going to take the original problem, and next to each fraction, I'm going to multiply in what is missing. In this first fraction, there's no x, so I'm going to multiply by x over x. In my second fraction, there's no x plus 4, so I'm going to multiply that in as well. I have 2 over x, but I'm missing this x plus 4 and x plus 4. I now have, for both denominators, a common one of x times x plus 4. Now my numerators are just the product of 1 and x, so that's going to be x. And then 2 times x plus 4. And I want to be careful to use parentheses. Since I have a common denominator, I can group this all into just one fraction whose denominator is x times x plus 4. And I'll add the x from the first fraction and the 2 times x plus 4 in the second. The only thing left to do from here is I'm going to leave the denominator alone, but I'm going to add the numerators. So to do that, I'm going to distribute this 2, and then combine like terms. And this is my final answer. 3x plus 8 divided by x times x plus 4. So it's abstract looking, but the idea behind it is the same as the two fractions that I started with. 3 and 5 have no common factors, so you can simply just multiply the two together to get a common denominator that works for both. Let's compare the previous example to this very similar looking rational expression. So I'd like to add these two things together, and to do so I need a least common denominator. If you look at the one on the left, it looks like I can factor it apart, so I'm actually going to start there where, okay, I'm not sure what the least common denominator is, but x squared plus 4x factors as x times x plus 4. To determine a least common denominator, you have to figure out what the factors are equal to. So I'm going to rewrite this problem. It's 1 divided by x times x plus 4 plus 2 over x. That's the same as the question we started with. This time, my least common denominator, if I look at the two denominators, I have an x and an x plus 4. If there was an x plus 4 over here, we would be done. So it turns out that our least common denominator is still x times x plus 4. The only difference is I don't have to adjust this first fraction. I just have to fix what's happening in the second one. So that's going to be my next step. I have 1 over x times x plus 4. Nothing happened there. But in my second fraction, I'm going to multiply by x plus 4 over x plus 4. When I do this, again, nothing's happening to the first fraction. But if I multiply the numerators and denominators of the second fraction, I get x times x plus 4, and then 2 times x plus 4. I now have a common denominator of x times x plus 4. At the top, it's going to be 1 plus 2 times x plus 4. So to completely simplify this thing, I'm going to, again, leave the denominator alone and simplify the numerator by combining like terms. This is 1 plus 2x plus 8 over x times x plus 4. And that's really 2x plus 9 over x times x plus 4. And this is my final answer. So the difference between this example and the previous one is I had to factor the first denominator to understand what common factors there were between the first and second fraction. Okay, let's try one more example. So let's see, I want to now subtract these two rational expressions. And if you can add two fractions, subtracting is not very different, so I'll throw this in here too. So to begin, I'm going to factor the denominators. Let's see, x squared plus 6x plus 8. That would be x plus 2 times x plus 4. And I'm subtracting 3. Okay, I have x squared minus x minus 6. Okay, so I get x minus 3 and x plus 2. Now that everything is factored, I can start looking for, well, what's the least common denominator? I see there's this x plus 2, so that has to be in both. But I'm noticing that, okay, this one has an x plus 4 and this one doesn't. And likewise for the x minus 3, there's one here, but there is one over there. To have a denominator that works for both fractions, I need both an x plus 4 and an x minus 3. Said another way, if I put an x minus 3 over here and I put an x plus 4 over here, my two denominators are going to be identical. So let's write it out. For my first fraction, I had an x plus 2, I had an x plus 4, it's just I didn't have this x minus 3, so why not multiply it in? I'm going to subtract off my second fraction. There was an x minus 3, an x plus 2, there wasn't an x plus 4, so I'm going to multiply that in as well. So this is a mess, but I can now just jump to one denominator, x plus 2, x plus 4 times x minus 3. Doesn't matter the order in which those three things are multiplied. But for my first fraction, the product of the numerators is x times x minus 3. I'm subtracting the product of the other two numerators. So again, really what we're doing to get our final answer is to simplify the numerator, not to multiply out the denominators. So I'm going to do this work separately. I want to simplify x times x minus 3 minus 3 times x plus 4. That's x squared minus 3x minus 3x minus 12. Or x squared minus 6x minus 12. This gives me my final answer of the numerator is x squared minus 6x minus 12. And the denominator is x plus 2 times x plus 4 times x minus 3.